Here is our second practice problem based on Newton's law of universal gravitation for physics grade 11. Here we have a question 5 that says, two satellites orbiting the Earth are situated on opposite sides of the Earth. Satellite A has a mass of 3,800 kgs and satellite B has a mass of 4,500 kgs. Satellite A is at a height of 25,000 kilometers above the surface of the Earth. Now, I know that it looks like satellite A and B are on the side of the Earth, but remember, if you were on the surface of the Earth, you would observe the satellite being above you. So we talk about it as being at a certain height above the Earth. Now, what I notice is that they have provided you with a diagram, but they do not have any of this information filled in on the diagram. So I'm just going to take a moment to actually fill in these values where they belong, so it's easier for us to understand what's going on. So here is all of the information that we have been provided with. I filled in the masses of satellites A and B. And I also want you guys to notice how I filled in the distance between the surface of the Earth and satellite A. Now, what's important for you guys to remember is that when it comes to calculations, especially when we have planets or spherical objects, we usually work with distance from their center, which means that if we had to do a calculation for Earth and satellite A, we would have to add on the radius of the Earth onto the 25,000 kilometers. Because for spherical objects, distances are taken from their center. Now, information like the radius of the Earth, as well as its mass, should be given to you on your formula sheet. Here, I've provided you with a table from your formula sheet for grade 11 from the Department of Education, where these values are actually given to you. And if you guys have a look at this, here we have radius of the Earth, and if we need the mass of the Earth, it is at the bottom. So the first question says, state Newton's universal gravitation law in words. I have provided it to you here, where it says every body in the universe attracts every other body with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So we have already established that these questions usually start off with a definition. So if you can learn your definitions, it does contribute to quite a bit of marks in your exam. 5.2 says, explain the term weightlessness. So weightlessness is something that you feel when all the contact forces that normally act on you are removed. So weightlessness can be described as the sensation experienced when all contact forces are removed. Now, moving on to the calculations, 5.3 says, calculate the force between the Earth and satellite A. Since we are asked to calculate a force, which is going to be this gravitational force, we are going to use the formula F is equal to G m1 m2 over r squared. And just in case you forget what G is, you can always get it from your formula sheet. It is going to be 6.67 times 10 to the minus 11. I am going to take the mass m1 as the mass of planet A. So if I refer back to this question, satellite A was given as 3,800 kgs. I'll take m2 as the mass of the Earth, which is from our formula sheet, 5.98 times 10 to the power 24. Now r, which represents the distance between these two objects, remember, is going to be the 25,000 kilometers plus the radius of the Earth. Because as I've mentioned before, when it comes to planetary bodies, which are spherical, distance is taken into account from the center of the body. So from the center of the Earth to its surface, that would be its radius. So we're going to take this 25,000 kilometers and add the radius of the Earth onto it. Bear in mind though, you guys, that 25,000 kilometers is not in the right unit. To convert from kilometers to meters, we multiply by 1,000. So I'm just going to add an extra 3 zeros to this. Onto that, I am going to add the radius of the Earth, which you can get from your formula sheet. It is 6.38 times 10 to the power 6. Don't forget to square. Now all you have to do is just plug this in onto your calculator, and the value that you should get is 1539.23 newtons. So question 5.4 says, what distance above the surface of the Earth should satellite B be to experience the same force towards the Earth as satellite A? Choose from greater than, less than, or equal to the distance above the Earth, and explain how you arrived at the answer. Obviously, you guys, in order for us to explain this, it is best if we use a calculation, okay? So yes, you can explain it in words, but since it is 4 marks, a calculation will be ideal. And based on our answer, we can then conclude whether it is greater than, less than, or equal to. Now, firstly, to understand exactly what we are calculating here, we want to know the distance between the surface of the Earth and the satellite. That is what we're solving for. Now, you guys can represent this how you want to. If you want to call it x, you can, which I'm going to go with. And just remember, with regards to the Earth, to the surface of the Earth, we have to add the radius of the Earth. So it's actually going to be the radius of the Earth plus x. Okay, so let's do this. Now remember that we wanted the force to be exactly the same. So we're going to use the answer that we had before, which was 1539.23. So that is going to go on the left-hand side. The value for G is 6.67 times 10 to the minus 11. Let's take mass 1 as the mass of the Earth, which is 5.98 times 10 to the power 24. Remember that we get from our formula sheet. The mass of satellite B is given as 4,500. And in the denominator, remember the distance between the Earth and satellite B is going to be the radius of the Earth plus x. And we need to solve for x. We are concerned with what x is. Radius of the Earth, we can take from our formula sheet, which is going to be 6.38 times 10 to the power 6. Plus that unknown distance x, and don't forget to square. Now here is what I'm going to do. Everything from this step onwards is just pure algebra. So there's actually no marks allocated to the next few steps, but I am going to show you how I got this, because it is important that you get the correct answer. Since I'm trying to solve for x and x is in the denominator, I am going to cross multiply. I'm going to take the value from the left and my bracket in this denominator and make them swap places with each other. So here's what it looks like after I've done that. The next step is we are trying to get to x, and what is holding x in this bracket is the square. To get rid of the square, we are going to square root, and we have to square root both sides since it is an equation. On the left hand side, when the square root and the square cancel out, we're left with 6.38 times 10 to the power 6 plus x. On the right hand side, this is what we get: 34,148,214.93. Now to get x alone, all I'm going to do is take that 6.38 times 10 to the minus 6 over to the right hand side, and it is going to subtract. Okay, so doing so, I've got 27768214.93 meters. Remember, the SI unit here is meters, which is absolutely fine as your answer. I do understand that some of you may be getting scientific notation if your calculator is going to be set to that format. So an alternative answer that you can have is 2.78 times 10 to the power 7 meters. So both answers here are accepted. Now that we are able to see what the distance is, we should match it up and conclude with our answer. So this value is 27 million. Okay, actually it's greater than 27 million. But if you look at the distance between the Earth and satellite A, when we converted it to meters, that was only 25 million. So obviously the 27,768,214 is greater than 25 million, which means that the distance between satellite B and the Earth is greater than the distance between satellite A and the Earth. So we are going to conclude and say greater than as our final answer.